So some of you might have noticed I did hit the record button. So one of the things that I like to do is I like to record our lecture and then I'll give you the link at the end of class, every class. So in case you guys are doing your homework and you want to review something that was said, in class, like I have it there for you. Um, I do encourage you to take notes as well. Um, but I do understand that because of the recording, you may not want to take notes. I get it, but whatever works for you, whatever works for you is best. Um, no problem if you can't talk. Sorry, you can just listen and you can always watch back in case you miss anything. All right. Just replying to a message. Anyway, da, da, da. Give me 1 second. I just want to grab attendance one more time. Someone just came in. Right. Should probably just do this at the end. But We'll we'll figure that out for tomorrow. All right. Anyway, so a little bit about me. Right. I'm alumni to BCC. So years ago, I was sitting in the same seats that you are now. Not at home in person, but like, so to speak. Um, BCC was a great experience for me. While I was here, I was on student government. I learned a lot. I majored in math and computer science. It was an enjoyable experience. Like BCC really built me up, I can't say that I came into the college strong, but I left the college very strong, and I was able to go to the 4 year school and do everything that I needed to do, which was really great. Um, Yeah, so if you guys have any questions related to BCC, you can always ask me. If I don't know the answer, I can probably direct you to somebody that could give you an answer. All right. So I'm a very useful person, so to speak. Let me give you guys my email real quick. This is all posted, by the way, in Brightspace. I was about to say the wrong thing. Everything is that I'm about to show you right now is posted in Brightspace, so you can totally go there and look it over, especially if you find my handwriting a little funny. So my email is Christopher dot Lee. I'm just gonna put a capital L because like the L sometimes can look like a 102 at bcc.cuny.edu. So in case you need me, please shoot me an email. You have a question about homework or anything, shoot me an email. I can't promise that I'm gonna get back to you immediately, but I'm gonna get back to you. All right. Sometimes, between work and stuff, I might be a little bit late with my email responses, but just know I'm gonna get back to you. All right. A little bit about me also. So in addition to being a professor, I also tutor in the tutoring lab as well. So if you notice that I have late emails, that could be the reason why. Like you might email me right now and then you might see a response 9 o'clock tonight kind of thing, and the reason for that massive um what you call it break in time in the reply is because of tutoring. I could be upstairs with students, and as you can imagine, talking for a living as a tutor, you don't have the time to be checking your email. So that's if you see delays in my email responses, just know that that's the reason why. All right. um I just mentioned the word tutoring, right? So we do have tutoring available. to everybody, I encourage you all to take advantage of it. Tutoring is found in CPH room 303, right? Let me write that down for you guys. That is CPH room 303. That's on the third floor, right? That's the same building that we have class in, right? Just on the next floor up, on the third floor. You guys are always welcome. We highly encourage you to go online and actually make an appointment to go to tutoring, all right? And then like you can sit down with somebody and go over whatever it is that you need to go over. But if this is a last minute thing and you just need a quick question answered, you are allowed to just walk in and ask that question as well. Tutoring is both in person and online, right? It's online via Zoom, right? So you guys can attend tutoring in whichever modality works best for you, or if you want to do both, be my guest, all right? You can go in person or you can go online, all right? So show you a couple of things real quick. To access tutoring online, one second. I'm just gonna reshare my screen real quick. All right. Once again, if you're just coming in, welcome. And everything is recorded, so don't feel bad if you missed anything. You can always go back and watch it. All right. Anyway, back to what I was saying. This is just a regular Google page, right? So if I go to this website right here, bcc.mywconline.net, or you can just Google BCC and WC Online, it's going to take you to this web page right here. Now, as I can imagine, this is everybody's first time, right? So for your very first visit, only for your first visit, you're going to click on right here where it says register for an account. And then all you have to do is just fill out this page. Again, this is just for your first time. This is not an every time thing, just your first time. You're gonna fill out your name, your email address, etc. Language spoken at home. Please input your EMPL ID here. Make sure it's correct. Your major. Create a password, right? If you want, and you can also choose how you want this website to communicate with you. Would you like them to send you an email, etc.? Right. I kind of like this thing, the iCal links, right? Like that's like a calendar link for your, like, I don't know if you guys use digital calendars. Like I use digital calendars. That's a link for the calendar. So you can just go into your calendar and just click like the link and boom, you'll be in tutoring. You can also set up text messaging as well. A lot of people don't really do this. I set it up for myself, so I get a text message every time somebody makes an appointment with me or not. All right, and then click "You're not a robot" and just create the account. All right. Once the account is created, go back here, right? You're just going to type in your email address and your password, and then it's going to take you straight into tutoring, right? These are your two options right here. If you want to tutor in person or if you want to tutor online. I noticed it says summer 2024. There may be a new tab there that's going to say fall 2024 for online and in person. So that should be the one that you're clicking on, the one that says fall. It could be that the link hasn't been created yet. Like as you can see for the writing center. Oh, by the way, we do share the same platform as writing tutoring. So that's why you're gonna see that here. And Perkins tutoring as well. We all share the same platform. Perkins tutoring is tutoring for other subjects like, just gonna throw out a few things off the top of my head: history, biology, chemistry, accounting, you guys can fill in the blanks, right? Different kinds of tutorings, right? And then the writing center is like if you need help with doing a paper or something like that, speech class, those kinds of things, right? I'm gonna log in with my stuff real quick. All right. Of course, I always get that wrong. Just to show you guys what it looks like, right? Now, I'm showing you the writing center because the one for math is not active at the moment, but it's going to look something similar to this, right? So on the left-hand side, you're going to see all of the available tutors, right? And then you see this dark blue color right here. This dark blue color is a time slot that you cannot select because the tutor is not there at that time, right? Anything that is blue, such as this color right here, that's a appointment that's been taken. So somebody has reserved that particular time, right? And anything that's white, like these over here, these are places where you can reserve time to actually go to see that particular tutor. What I recommend for everybody, nope, not there. There's a way, just up here in the tools, right? It's in the schedules, no. All right. For the most part, I'm just gonna say this generally, right? For the most part, pretty much everybody that works in tutoring can help you with this class with 28.5. You might have one or two exceptions, but for the most part, everybody can help you with this class. So you can literally make an appointment with anybody. There is one or two people that might not have the skill set to help you, but in the event that you make an appointment with them and they were not the right choice, they will quickly just move you to the correct choice. And then going forward, not to choose that person again. Right? So that's that. And then to make the appointment, again, you just click on the white space, right? You tell them what time you want the appointment for, and then any if there's anything that you want them to look at, etc. And then you just create the appointment. Long story short, that's it. And that's how you make an appointment for tutoring. All right. Now, when it comes to me and office hours, right? You can make an appointment to see me in office hours through tutoring, right? So what I've done is my office hours, I've merged them into the tutoring lab. So anytime you need to see me like in person, just make an appointment and come see me. And however long you make the appointment for, the time is yours, right? If it's something that's little and you can send me an email, go ahead and send me an email. Again, I might not reply to you immediately, so just be aware about that. All right. And again, tutoring in person is in CPH 303. Tutoring online will be via Zoom. Now, when you make the appointment for online, they're going to send you an email, right? And in the email, that email will have the link for Zoom. The link constantly changes, so there's no generic link that I could give you right now that would work for the rest of the semester, for example, right? So the only way to really do it is to make the appointment online. For if you want online tutoring, I'm talking about now. Make the appointment online, and then you'll get the link, right? So what that means is that for online tutoring, there's no walking in. That's the only disadvantage about online tutoring. But for in person, you can walk in at any time, regardless of an appointment. However, we do strongly encourage you to make an appointment. All right. Tutoring times are going to be, and I'm totally copying this from the computer, so I might be wrong about this, and if I am wrong, I'm going to correct myself on Tuesday. Okay, I'm going to correct myself on Tuesday. But from what I can see online, tutoring is Monday through Thursday. right? 11 a.m. to 8 p.m. And then Friday through Saturday, right? 12 p.m. to 6 p.m. All right. Now, I might be wrong about this. The times may change. I will correct myself on Tuesday if the times change. These times are for both in person and online at the same time. They work simultaneously. Okay. So that's for tutoring. As far as homework is concerned, I did send out a message about homework, right? So you guys can find homework on WebWork, right? If you guys look at your announcements for Brightspace, excuse me, uh, lost for words. Like you can find your homework on WebWork, right? You guys to log into WebWork, your first name and last name. That's going to be your username and your password. First name and last name, right? So for example, let's say that my name was Jane Doe. I'm making up something, right? Jane Doe. That's the name, right? The username and password for the web work will be Jane Doe. One word, no space in between, just just like that, right? Lowercase letters as well, right? And that's the username and that's the password, both of them. All right. You guys can log in and take a look at your homework right now if you want. All right. If anybody has any trouble logging in, by the way, please contact me. Please let me know. All right. I want to make sure that everybody can get in no problem. The link for homework is also online, but let me see if I could just post that in the chat real quick. Just bear with me 1 second. So first thing I just posted, this is the link for the making an appointment for tutoring. All right. And also that's the same way that you'll make an appointment to see me in case you need to see me for office hours or anything. But anyway, back to what we were saying. The link for the homework. I'm gonna give that to you 1 second. All right. There you go. So that's the link for your homework. All you have to do is just click it. You type in your username and your password, right? Which is again your first name and then your last name, all lowercase, one word, right? Username and password, same thing. Click enter, and there goes your homework. All right. There's a post on Brightspace that explains this, right? But if you have any trouble, please don't hesitate to shoot me an email. All right. Um, that's that. For our class that we're gonna have together, I'm just gonna talk a little bit about the grade breakdown. So our final exam is gonna be worth 33% of our overall grade, right? Our in-class test will be worth 30% of the grade, right? And what's gonna happen is I'm gonna give you 3 tests that are in class, right? I'm gonna take the best 2 of 3, so I'm gonna drop your lowest one. So it's okay if you have an off day and you miss a test, right? That happens, like we're all human. And last but not least, the homework is going to be worth 37% of your overall grade. So please do the homework. All right, please do the homework. A matter of fact, I'm gonna even give you guys a little tip. All right. The best way to do great, not good, great in mathematics is to do the homework. All right. Once you do the homework, there's nothing that I could throw at you that you won't understand and you won't be able to do. All right. Do the homework. All right? It's all on the website. You have unlimited attempts when doing your homework. I'm not interested in you doing the homework in two attempts and then you get the right answer and then that's it. Like however many attempts you need to get the answer right, that's all I care about, right? I care about your process, right? I want you all to get the process down packed. I want you all to get 100 on the homework if possible. All right. You have no penalty for trying a question multiple times. So just do whatever you have to do to get the right answer to get the 100. That's it. All right. However, on your test, you only have one shot, right? So another thing too, please try and stay on top of your homework. All right. We're going to be moving at a good pace through this class, but it's really easy to fall behind, right? Stay on top of your homework, right? It's okay if you can't do it all by yourself. That's what tutoring is for. All right. Please don't sit there and be lost for the whole semester. If you need help, seek it out. And please don't feel no shame for seeking out help. I'll tell you, as a like me, when I was a student here, right? And now I'm a professor, right? I always went to tutoring, right? I went to tutoring to do my homework. Did I use the tutors when I was going to tutoring? Not really. It was just a comfort to have them next to me, right? But I did all my homework in tutoring, right? They have scrap paper there. I did all my homework on the scrap paper, right? And then I would hand it in to my professors. Sometimes I didn't have a pen. I'd take the pen from the tutoring lab. That's how I got through BCC. I'll be honest, right? So the help is there. All right. There's no reason for any of us to fail the class or to be lost. The help is there. All right. And once again, everything that I'm talking about, it's in the on Brightspace. It's in the announcements. Just take a look. All right. So something else that I would love to go over with you guys. Would love to go over the syllabus with everybody. Just right before we jump into the class. Bear with me 1 second. All right, here we go. All right. So this is our syllabus for the class, right? Ooh, wrong one. Hold up. I made a boo-boo. That's the wrong syllabus. Second. But this is actually good for you guys because you guys can actually see where the syllabi are, right? So you can check this out for any class that you have at BCC. You're going to see my process right here. So we're doing math and computer science, right? Go down to where it says degree programs and courses, right? And then we just go down to our class. So we are 28.5, right? We're in the harder class, right? So now, right, we have our syllabi right here. Let me open that up. That's the one that I wanted. That's the one I wanted. Boom. Here we go, right? So as you can see, these are our textbooks, right? So we're going to be using the OpenStax textbook. We have the Algebra 2 for pretty much the entire class, right? And then we have a little touch, a little sprinkle of pre-calculus at the end, right? Not too bad, just a little trigonometry. Some of you might have seen it already. Nothing crazy, nothing crazy, all right? So here we got our course description, right? Fundamentals of elementary, intermediate, and college algebra, essential for the studies of pre-calculus and calculus, right? Here's some of the topics we're going to be doing: linear equations, polynomials, factoring, roots and radicals, rational expressions, quadratic equations, the function concept, and the trigonometric ratios, right? That's at the end, trigonometric ratios. right? And some other interesting stuff about seeing how this fulfills your requirements for pathways and all of that. You guys can read that on your own, right? Academic integrity, please do your own work. Please try, all right? Please try the work when you're doing it. Don't, in my opinion, don't go to tutoring and have the tutor do every single question for you in your homework, right? Try the homework yourself, do what you can, and the one or two questions that you're not understanding, then ask a tutor for help, right? That's the best way to go about this. All right, so please try your best, try your own work. All right. Remember when you go to tutoring and stuff, the tutor is not there with you on the day of the test, right? You're there by yourself. So you have to learn how to do this so that you can be able to pass your test in class. All right. Um, accommodations, right? So if anybody is owed accommodations, please let me know, right? If you feel like you are owed accommodations but you haven't registered with the office, here's all the information that you need to do it, right? So the email is disabilityservices@bcc.cu.edu. They're located in Lowell Hall, room 211, and this is the phone number. All right. If you need any accommodations, please register with them. Let me know in private like what it is that you need, and we'll work with you. We'll work with you. Long story short. All right. Let's get down to let's go down to business here, right? So this is our class. This is what we're going to be doing for the whole semester, right? Every section broken down, right? These are the recommended homeworks from the textbook, right? These are not your web work homeworks. These are the recommended homeworks from the textbook. All right. If you guys feel you need to do extra practice, this is your extra practice right here. All right. And then you can see all the sections, everything that we're going to do, all broken down. And that's your syllabus. All right. If you guys have any further questions, shoot me an email. Come see me in tutoring. Oh, another thing I forgot to tell you about tutoring. Tutoring doesn't start until September 3rd. So they are not open right now. Next week on Tuesday, I believe. Yeah. September 3rd, which I think is Tuesday. That's when tutoring will open. All right. I think Monday is Labor Day. I might be wrong about that, but I think it's some kind of holiday and then school is not open. Right. I don't know if you guys heard anybody else tell you that in class, but I think school is closed on Monday. All right. So that being said, let's jump into our first topic for the semester. Right. Um, I'm not gonna lie, like this topic is very um elementary, and I know that pretty much everybody that's in this class right now knows this topic, but just humor me for this first day, right? I'm so happy that we're actually doing this particular topic online and you guys didn't have to travel to school for this topic because it's simple, right? But it's something that we have to do. So let's get into it, right? First thing we're going to be talking about integers, right? Integers. So an integer, right, is a type of whole number that includes negatives, right? But before we get into all of that, let's talk about natural numbers, right? Natural numbers are the numbers that we grew up with, right? These numbers are the numbers that we learned when we were real little counting, right? So 1, 2, 3, 4, and you get the idea, right? So those are our natural numbers, right? Now, we want to introduce something more on top of that, right? We want to add in 0. So we're going to add 0 to this mix. And we want to add in the negative numbers, right? So like -1, -2, etc., right? And then that is what we call integers, right? So integers are all the negative numbers, -3, 2, -1, 0, and all the positive numbers, 1, 2, 3. Right? Is that clear? Does that make sense to everybody? See, I have a message in the chat. Awesome. Awesome. Okay. So that being said, right? What do I want to do with these integers, right? I want to do expressions with them, right? I want to add them. I want to subtract them. I want to divide them. I want to multiply them, right? So that's what we're doing today in a nutshell, right? Before we get into all of that, let's just cover our basics real quick. And again, I know you all know this. I don't mean to insult anybody. We're just like dotting all our I's and crossing our T's with this lesson. So the first thing we want to do is we want to simplify expressions with absolute value symbols. So a negative number is a number that's less than 0. So the negative numbers are to the left of 0 on the number line, right? As you can see in this figure, right? This is a number line, and we have our negative numbers on the left of 0, right? And we have our positive numbers on the right of 0, right? Positive, negative, right? So number line shows the location of positive and negative numbers. You may have noticed that on the number line, the negative numbers are a mirror image of the positive numbers with 0 in the middle. Because the numbers 2 and -2 are the same distance from 0, each one is called the opposite of the other. So the opposite of 2 is -2, and the opposite of -2 is 2, right? Got you. Now, one thing you're going to know about me, I like to repeat myself. So don't be alarmed if you hear me repeating myself. I do it on purpose. All right. So opposite. So the opposite of a number is the number that is the same distance from 0 on the number line, but on the opposite side of 0. All right. So that's the definition of opposite. All right. For example, let's say I have 3 and -3. All right. So the opposite of +3, which is right here, is -3 on the other side of the number line. All right. For example, let me know if I'm going a little fast. I am kind of taking this lesson for granted. I feel like everybody knows this, but let me know. And I'm gonna ask everybody just to stick around for a few minutes at the end just so I can take attendance. Just letting you guys know. So opposite notation. -A means the opposite of the number A. So the notation, -A, is read as the opposite of A. All right. Me personally, I like to say negative instead of opposite. This is a habit that I have well ingrained into my head. Whoops. Good. So we saw that numbers such as 3 and -3 are opposites because they are the same distance from 0 on the number line. They are both 3 units from 0. So the distance between 0 and any number on the number line is called the absolute value of that number. All right. This is a really, really important concept. All right. This is the reason why anytime you take the absolute value of a number, the answer is always positive, right? Because we're looking at how far away it is from 0, not necessarily what the number is itself, if that makes sense, right? So absolute value. So the absolute value of a number is its distance from 0 on the number line. The absolute value of a number n is written as those two lines right there. They're called absolute value. So absolute value of n. And the absolute value of n is always greater than or equal to 0 for all numbers. Absolute values are always greater than or equal to 0. Right? Guys, a little example real quick. Absolute values. Fun stuff, fun stuff. All right. So for example, -5 is 5 units away from 0. So the absolute value of -5 is 5. 5 is 5 units away from 0. So the absolute value of 5 is 5, right? And then figure 1/4 illustrates this, right? You see how -5 is 5 units from 0 and +5 is 5 units from 0. All right. Is there any questions about this? Does this make sense to everybody? Things good? All right. All right. So let's move on. Again, if I'm going fast, just let me know. I'm kind of taking this lesson for granted a little bit. And please don't feel ashamed to ask a question because I guarantee somebody else is sitting in the room and they have that same question too. All questions are welcome here. Okay. So the absolute value of a number is never negative because distance cannot be negative. Only number with absolute value equal to 0 is the number 0 itself because the distance from 0 to 0 is on the number line is 0 units, right? So that's something to keep in mind. And now we're gonna build up our toolbox a little bit. All right. Let's build up our toolbox a little bit. We now add absolute value bars to our list of grouping symbols. When we use the order of operations, first we simplify inside the absolute value bars as much as possible. And then we take the absolute value of the resulting number. All right. So you're gonna simplify inside of the absolute value, then do whatever's on the outside. All right. So just to kind of remind us, talking about here, these are the grouping symbols, right? We just added the absolute value to our grouping symbols, but I'm sure you guys have seen parentheses before. I'm sure you've seen brackets before, braces before, and now we're talking about the absolute value, right? All of these symbols, right? We group our numbers together. So you always do what's on the inside first before you do what's on the outside, right? Evaluate the inside before the outside. Right? But I think it's time to have a little bit of fun, right? So let's look at an example. I'm sure those of you that are into social media, you'll see questions like this often posted, and they'll ask you, hey, what's the answer? I love these questions. Everybody always has like some kind of wrong answer or something, and you have one or two people that get it right. Oh, this is the best. These questions are the best. All right, so we want to simplify. 24 minus the absolute value of 19 minus 3 times 6 minus 2, right? So the first thing that I want to do is I want to do what's in the parentheses, right? So that's 6 minus 2. So that's going to leave me with what? I'm going to have 24 minus the absolute value of 19 minus 3 times 6 minus 2. What's 6 minus 2 again, somebody? What's 6 minus 2 again? You can type it or you can say it out loud, no problem. All right, I got 4. Thank you, thank you, thank you. I only have 5 fingers, so I can't use the sixth one. Right? Cool. So now, right, I want to simplify what's inside of the absolute value symbol. Right? So I'm still gonna have the 24 on the outside here. So 24 minus absolute value. But now I want to do what's on the inside. So I'm gonna have 19 minus what's 3 times 4 again? Awesome, 12, right? Whoops. Sorry. Minus 12. What's that doing there? There we go. And then now we just do our subtraction, right? So now we still have the 24 minus on the outside, absolute value. Now 19 minus 12, what's that? What's 19 minus 12? 7, right? So now I want to take the absolute value. Sorry about that. I want to take the absolute value of 7, right? So 7 is 7 units from 0, right? So that's just going to leave me with 24 minus 7. And then now we just do the math, right? 24 minus 7, what's that, like 17? You guys should check me on that. Y'all got 17 for that? Awesome, awesome. Right? And that's it. That's the whole process in a nutshell, right? You simplify what's on the inside of the grouping symbols, and then you do whatever's on the outside last. That's it. Any questions on this? Anybody? Oh, okay. Sounds good. Sounds good. I'm gonna let you guys try one real quick. Go ahead. You guys try one. I'll fall if anybody was still copying. There you go. Give you guys like 2 minutes to try that out. All right, awesome. Let's take a look. Let's take a look. So in this question, whoops, that keeps happening. I have 19 minus the absolute value of 11 minus 4 times 3 minus 1. 3 minus 1 we know is what? I think 2. And then boom, right? Then we're going to have 19 minus the absolute value of 11 minus 4 times 2, I think is 8. And then we're going to have 19 minus absolute value, 11 minus 8, I think is 3. So this becomes 19 minus 3, which is 16. Awesome, awesome, awesome. Any questions on this? Everybody got it? Awesome. All right, if there's no questions, let's move on. I'm gonna take it up a notch real quick. Nothing crazy. Everybody here knows how to do this already. All right. So we're gonna add and subtract integers. So far, we have only used the counting numbers and the whole numbers. So counting numbers are 1, 2, 3, right? Whole numbers are 0, 1, 2, 3. Our work with opposites gives us a way to define the integers. The whole numbers and their opposites are called integers. The integers are the numbers, for example, -3, -2, -1, 0, 1, 2, 3. All right? Those are our integers. Just so I'm clear. Integers. So the whole numbers and their opposites are called the integers, right? The integers are the numbers -3, -2, -1, 0, 1, 2, 3. Those are integers. Now, when it comes to addition and subtraction, there's many different ways to do it. If you have a method and a way that works for you and you always get the right answer, I'm okay with you tuning out what I'm about to say. But if you have trouble with negatives, for example, you can add regular numbers, but when it comes to the negatives, you don't know what to do. I hope that this, what I'm about to show you, will help. All right. So that being said, most of us are comfortable with the addition and subtraction facts for positive numbers, but doing addition or subtraction with both positive and negative numbers may be more challenging. We will use two color counters to model addition and subtraction of negative numbers, right? So that you can visualize the procedures instead of memorizing rules, all right? So we want you all to see this, right? I want you all to get this. Right? So we let one color blue represent positive, and the other color red will represent the negatives, right? So positive is blue, negative is red. Okay. Okay. So if we have one positive counter and one negative counter, the value of the pair is 0. They form a neutral pair. So the value of this neutral pair is 0. So 1 plus -1 is equal to 0. We will use the counters to show how to add, for example, 5 plus 3, -5 plus -3, -5 plus 3, 5 plus negative. The first example, 5 plus 3, adds 5 positive and 3 positive numbers, both positive, right? The second example, -5 plus -3, adds 5 negatives and 3 negatives, so both negatives. When the signs are the same, the counters are all the same color. So we can add them. In each case, we get 8, next to me, we get -8, no, we get 8 and either 8 positive or 8 negative. So let's look. So I have 5 blue circles, dots, whatever, and I have 3 circles, right? I want to add them together. So 5 plus 3, that gives us 8. And the negative side, right? I have -5, let's say, which is red, 5 red dots. And I have -3, which is 3 red dots. I add them together, -5 plus -3 is equal to -8. So what happens when the signs are different? Let's add -5 plus 3 and 5 plus -3. When we use counters to model addition of positive and negative numbers, it's easy to see whether there are more positive or more negative counters. So we know whether this to sum will be positive or negative. So let's look at this. I have -5 plus 3, right? More negatives, the sum is negative. So -5 plus 3 is -2. These two cancel each other out, right? Anytime I have a blue and a red, they cancel out. And that's how I got the -2. So 5 plus -3, right? These are canceling out, are leaving just two positive numbers. So 1 plus 1 is 2. And that's it. More positive, the sum is positive. So 5 plus -3 is equal to 2. This is a really complicated way of saying that you keep the sign of the larger number. I don't know if anybody ever heard that said before, but that's keeping the sign of the larger number. No problem. I understand things happen with logging in and out. All right. You guys try this while I get something to drink. 1 second. All right, okie dokie. Let's take a look at this. I'm gonna look at number one, right? I have one negative circle plus four negative circles, right? When I put those together, what do I get? I get five negative circles. So what does that equal? That equals negative five. So negative one plus negative four is equal to negative five, right? Let's look at B. Let's look at B. So for B, I have one negative circle, and I'm going to add five positive circles to it. So one, two, three, four, and five, right? Now, if you look real closely, these two are on top of each other, so they're going to cancel out. So what am I left with, right? I'm left with four positive circles. So negative one plus five is four, right? Let's look at one plus negative five, right? So I have one positive, wrong color, sorry about that. Sorry about that. So I have one positive color, and I have five negative colors. So one, two, three, four, five, right? Now again, we notice these two, right? They're going to cancel out because one positive and one negative cancels out. So what am I left with, right? I'm left with four negatives. So what does this equal? Negative four. So one plus negative five is negative four. Long story short, keep the sign of a larger number. That's what we're trying to illustrate here. Right? No problem, Franklin. I understand. No problem. I'll give you guys a question to try real quick. And we'll look over it in a minute. All right, let's take a look. So I heard someone tell me that A was -6. I agree. All right. If my circle example helps you, by all means use it. All right. But if you can look at this and figure out what the answer is, I'll take that as well. So what about B? What's the answer there? Awesome. That's what I got. I got 2 as well. How about C? What we got? Awesome. 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 So I got -2. All right. Is there any questions about this? Does anybody need to see me do any one of these over with the circles? Everybody's good? All right. Awesome. Let's move on. And if you guys need more examples or anything, like, please, like, don't hesitate to ask. Okay? Like I said, no wrong, no bad questions here. Everything is good. So we will continue to use counters to model the subtraction. Perhaps when you were younger, you read 5 minus 3 as 5 take away 3. When you use counters, you think of subtraction the same way. So we will use the counters to subtract 5 minus 3, -5 minus -3, -5 minus 3, and 5 minus -3. All right. And again, if you have your own method and it always works, like, please don't let me rechange your method. All right. As long as you all get the right answer, that's what I'm looking for here. To those of you that have been getting the answer wrong, right? This is a new technique for you to add to your toolbox to hopefully always get the right answer. So the first example, 5 minus 3, we subtract 3 positives, right? From 5, excuse me, we subtract 3 positives from 5 positives and end up with 2 positives left. So in the second example, right? Well, before I even do that, I'm looking right here at the first example, right? I have 1, 2, 3, 4, 5 positives, right? And I'm going to take out 3 of them, right? That's the -3. And what am I left with? 2 positive numbers. That makes sense, right? In the second example, I have -5 minus -3. So I have 5 negative circles, right? They're 5 red circles. I'm going to knock out 3 of those red circles. So boom, they're gone, right? What am I left with? I'm left with 2 negatives as my answer, right? So that's 5 minus -3. Questions on this? Is this clear? I know this could be a little tricky to some, so please, like, ask any questions if you have. Awesome. I'm glad they're simple. Your homework is just as simple as well. In fact, I know some of y'all are quiet because y'all doing the homework in the background, not saying nothing. That's okay. I'm not mad. Go ahead, it's posted already. That's okay. All right. So what happens when we have to subtract one positive and one negative number? We'll need to use both the blue and the red counters as well as some neutral pairs. If we don't have the number of counters needed to take away, we add neutral pairs. Adding a neutral pair does not change the value. It is like changing quarters to nickels. The value is the same, but it looks different. All right? Just to be clear, just to be clear. So I'm gonna just do this in a little bit of a chart form because I feel like we're getting deep here. It's real easy to like lose each other. All right, so I'm just gonna do this in a little bit of a chart form. All right. So let's say I want to do -5 minus 3, right? So okay, I have how many circles there? I have -5 circles, and I want to take away 3 positive circles from there, right? So I need to add a neutral pair, right? The neutral pair here is going to be 3 negative circles and 3 positive circles, right? So we're going to then remove the number of counter models by the second number. So what am I taking away here from the neutral pair? I'm taking away 3 positive numbers, right? Because it's -5 minus 3 positives, right? So I'm knocking out the positives right here. So what am I left with? I'm left with 1, 2, 3, 4, 5, 6, 7, 8. I'm left with 8 negative circles, right? Counters. So -5 minus 3 is -8. All right. Now let's look at another question, right? I have 5 minus -3. So I have 5 positive counters, right? 1, 2, 3, 4, 5. I'm going to add in, right, some neutral pairs, right? Because we're doing subtraction. So anytime you do subtraction, you add in neutral pairs. So I'm going to have 3 positive and 3 negative, right, pairs that I'm adding in. But let's go back to the question. The question is, what is 5 minus -3, right? What is 5 minus -3? So I'm going to take away the -3 pairs. So now what am I left with? I'm left with 1, 2, 3, 4, 5, 6, 7, 8. I'm left with 8 positive counters. And that's the answer. All right. Does this make sense to everybody? Does anybody have any questions? So homework is on WebWork. That's where you can find it. There is a link for it in this chat as well. Let's see if I get you that real quick. And then the password and the username is your first name, and your last name, all in lowercase as one word. And yes, the bigger number is a sign that takes over. That's true. Okay. So if there's no other questions, all right, let's try an example. I'm just trying to offer those of you that need it a technique so that you can get through operations with negative numbers. If I'm being totally transparent with you guys, I personally do not use counters whenever I'm doing this type of math. Right? I kind of think about the numbers on the number line if necessary, and I answer the question straightforward. Right? So let me show you an example of what I mean without using the counters, because I do feel like counters they're nice in the beginning when you have nice numbers, and then when you have like double digit numbers, triple digit, like we can't do that. That's too much, you know? But let's look at A for example, right? So I'm gonna do this once with the counters. So I have 3 positive circles, and I want to subtract 1 positive circle from it, right? So I have to add in a neutral pair. So what's my neutral pair? Boom. There goes my neutral pair right there, right? Gonna knock these out. So what am I left with? I'm left with 2. So 3 minus 1 is 2. Right? Not my favorite way of doing things. I'd rather just go straight forward. Let me share with you how I think about these types of problems here. So I have -3 minus -1. Decisions, decisions, decisions. So here's how I would do this. This is not using the counters. This would be my way. I keep the first term, right? -3, right? Now, you notice how this is a negative and a negative together, right? So let me do it like this. Makes more sense, right? To me, a negative and a negative through multiplication, negative times negative, makes a positive, right? Another way to think about it or set a little bit differently, right? If I wanted to write a addition sign, how many strokes do I need? I need 2 strokes, right? You can't make a positive sign with just one, right? So the first stroke, boom, going down. The second stroke, boom, going across. Positive sign. I don't know if that helps anybody, but in my head, this is what I came up with. And it always works for me. So -3 plus 1 is just very simply -2. Again, if you like the technique, take it. If you don't like it, you don't have to use it. Awesome. So let's look at C, for example. I'm going to change the color because this is uh, kind of getting squished up a little bit. So -3 minus 1. -3 minus 1. This is the way I think about it. Again, not using the counter, right? So I owe $3 to the deli, right? I owe $3 to the deli, and I just picked up something else, and now I owe them another dollar. So how much do I owe them in total? Right? I already owe them $3. I'm picking up something else. Let's say I'm picking up a water. So now I owe them another dollar. So how much do I owe them in total? Right? -4. Right? So -3 minus 1, right, is -4. Again, I don't know if this helps anybody, but this is how I do it in my head, right? For D, I do the same thing as I showed you before, right? I keep the first term, 3, and then now I have 2 strokes, right? So this is going to be across, right down, that's positive, and then make the 1. So 3 plus 1, what's that? 4. Is there any questions on this? Any at all? I don't want to confuse anybody. Any questions? Awesome, awesome. Well, please don't feel shy. If you have a question, please ask. Somebody sitting next to you might have the exact same question and you might not even know that. Here, you guys try one. Now, when you guys look at your homework, you might see the number of questions and be like, oh my gosh. But I promise you, each question is like this. One was 6 minus 4. Type in the answer, click enter, move on to the next While you guys are working on that, by the way, it just occurred to me, today's Thursday, right? So I don't know if you guys know this, but Thursday is normally when we have um club hours on campus. So a lot of activities happen on Thursday. Today on campus, because I'm on campus right now, I don't remember seeing anything spectacular happening on campus. I want to say in the library they were giving out free food, but that's about it that I know of. So in the future going forward, like just letting you guys know, um, Thursdays on campus is when clubs are meeting and activities and things are happening. Just letting you guys know. By the way, I know everybody got the updates, the announcements on Brightspace, but I don't know if this might help some people. There's an app. It's called Pulse or Brightspace Pulse or something like that. It's in both the App Store and the what's the one that they call for Apple? I forget if that's the App Store or whatever, but it's in the Android market and the Apple market, right? You guys can download it for free. I highly recommend you guys download those apps. It'll that app in particular, excuse me, it'll give you an alert on your phone whenever an update or a change was made to your classes, so that you guys can like stay on top of everything. App Store, Google Play Store, yeah, yeah, yeah. It does look like a health app. You're right. Well, at one point, I was trying to see if my Fitbit could connect to it. That way I could like monitor the class and my heart rate at the same time. It could show a spike in my heart rate when everybody gets 100, and I'm just like, what did I do wrong on the test? And nobody got nothing wrong. All right, let's take a look at this. Oh, this always happens. Okay, so for A, right, I have 6 minus 4. Feel like that's 2. All right. For B, I have -6 minus -4, which becomes -6 plus 4, which for me would be -2, right? And then for C, let's take a look. I have -6 minus 4, which for me would be -10. And then for D, I would have 6 minus -4 would become for me 6 plus 4, right? Because I have 2 strokes, and 6 plus 4, I think, is like 10. Right? All right, so those would be my 4 answers. Does anybody have any questions, or does anybody need to see me go over any one of them? You got the B wrong? All right, that happens. That's no problem. All right. So with the B in particular, right? The first thing I did, I have -6 minus -4. Because I have the 2 strokes, right? Oh Lord. Sorry, I didn't mean to do that. A second. Oops. Sorry about that. All right. Because I have the 2 strokes right here, right? I know that they're going to become the plus sign, right? So -6 plus 4. Now, how do I know that -6 plus 4 is -2, right? Now, the generic old way of doing it is saying whenever you have different signs, you subtract and keep the sign of the larger number, right? Said a little bit differently, another way to think about it, let's say that I have a number line here, right? Trying to think what I want to do. Let's say that this is like -8, -7, -6, 5, 4, 3, -2, and -1. Ran out of space, right? What's happening is I'm at -6, right? And I'm going to add 4 to it, or said a little differently, I'm going to move 4 spaces to the right in the positive direction, right? That will give me the -2. I don't know if that helps thinking about the number line. For me, I'm always thinking about the number line when I'm doing these and I'm using the strokes and everything. Like that's what makes the most sense to me. But I can do the counters as well if that is possible. And then okay, so you got D wrong also. Yeah, so with the parentheses, right? Best way I could tell you, anytime you have this minus sign next to something in parentheses, think of it as a multiplication, right? It's like -1 times -4, which makes +4. Or if you want to do the little stroke thing that I'm doing, right? Bring down this minus sign here, and then to add another stroke to it, put it up top, and now it becomes a plus sign. So 6 plus 4. And then we all know how to do that, right? Just count on your fingers, 6 plus 4, 10. Boom. Right? So that's another way to do it. But don't worry, in your homework, you'll get plenty of practice with this. So this is not like your only example and then we're moving on. You have your homework where you
Excuse
can
me.
go ahead.
About the homework. To sign in, you said what's my username and password?
So it's your
Like,
first name and then your last name as one word with no space, all lowercase letters. Excuse me.
and then the password would be what?
The same thing. Username and
Oh,
password,
okay.
the same thing. Yeah.
All right, thank you.
You're welcome. You're welcome. Yeah, so if anybody's like bored with the lesson, and believe me, I understand if you are, 'cause I know we're doing very basic stuff today, you can go ahead and start your homework. I won't be mad. I get it. So let's talk about this a little bit more, all right? So have you noticed that subtraction of sign numbers can be done by adding the opposite? In the last example, -3 minus 1 is the same as -3 plus -1. And 3 minus -1 is the same as 3 plus 1. You will often see this idea, the subtraction property, written as follows. All right, so now we're taking it up a notch. Now we're going to look at the subtraction property. Okay. So by the way, these gray boxes that you see me posting right here, like this one that says subtraction property, in class, I'm going to give you guys a formula sheet. And in that formula sheet, you're going to have these generic formulas, right? You will be able to use them on your test. You'll be able to use them on the final as well, the formula sheet. So all you have to do is just learn how to read it. And that's what we're going over right now. So subtraction property. A minus B is equal to A plus negative B, right? And we're subtracting a number is the same as adding its opposite, right? So A and B are any numbers that you want to put in there, right? So whenever you subtract two numbers, A minus B, you can either subtract it that way or you can just add its opposite. So A plus negative B. That's what it's trying to illustrate to you there. This idea sometimes comes in very handy. I mean, me personally, I kind of use these interchangeably all the time. And I kind of do it to make life easier. So I do it depending on the larger number that I'm dealing with. You know? So let's take a look. Let's take a look. I feel like I'm leaving you guys in suspense. Let's take a look. All right. So let's say for the first one, A, right? We want to simplify 13 minus 8 and 13 plus -8, right? They are both the same question, right? 13 minus 8 is equal to 13 plus -8, right? They're the same thing. So let's do it. 13 minus 8, what's that, 5, I think. And that's it, right? Two different ways of thinking about the same idea, the same question. Let's look at B. I have -17 minus 9, right? And I'm telling you that that is the same thing as -17 plus -9. It's the same thing, right? So obviously they're the same sign, so you know that the answer is going to be negative, right? And you're just going to add them together. What's 17 plus 9? What's that, like 26? So -26 is my answer. It's that simple. It's that simple. All right. Let me try C. The C, I have 9 minus negative 15. Now you already know my trick, right? That negative negative is going to become what? A positive, right? So it becomes what? 9 plus 15, which is what? I feel like that's 24, maybe. Y'all should check my math on that. I'm over here counting my fingers. Y'all smarter than me. All right. So then now we have D. Let's take a look at this, right? I have negative 7 minus negative 4, right? And I'm telling you that that's the same thing as doing negative 7 plus a positive 4, right? Now, for me, the negative 7 plus 4 is the easier one, right? So if I subtract these, 7 minus 4 is 3. The 7 is a larger number, so my answer is negative 3. And that's how I would do that one. Is there any questions on this? Any at all? Please, don't hesitate.
I don't got a question about this, but you said my username was
Hmm.
everything lowercase, right? I don't think it's
Yeah,
working.
it should work. If it doesn't work, stay after class a little bit, and then we'll see if we can get that fixed.
All right, bet I got you.
So yeah, there's no questions on this. Let's move on a little bit. I know I kind of went through that one. I don't want y'all to feel cheated, so let me let y'all try one quick. Go ahead, give that a try real quick. Give y'all a couple minutes to try that out. Real quick, it was Franklin that was asking about the username.
Yeah, what's up? How you doing?
Okay, good, 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 good.
So, sir, for the homework, we just
Uh-huh.
writing it on a piece of paper and then taking a picture, right?
No, just type it in web work and click enter. Like it grades
Oh,
you right
okay.
there. Yeah, and
All
you
right, bet.
can try it as many times as you want, no penalty. Just get 100. That's all.
All right. Thanks.
You're welcome. You're welcome. All right, so let's take a look at this, right? Look at A. So for A, I have 21 minus 13, which is the same thing as me saying 21 plus negative 13. Now, for me, I think the easier one is 21 minus 13, which I think is 8. Am I right about that? So I should check. I think it's that. All right. One second, real quick. All right. Let's keep going. I want to change the color real quick. Let's go with the BCC green, right? Go Broncos. So we have negative 11 minus 7, right? Which is equal to negative 11 plus negative 7. Now, to me, negative 11 plus negative 7 is the easier one. So that's going to be negative 18. Again, just my preference, whatever works for you. That's and gives you the right answer. That's what you should be using. 6 minus negative 13. We already know. I like to do my stroke thing. This becomes 6 plus 13, which is, I don't know, 19. Preference. So let's look at D. I have negative 5 minus negative 1, which we know is the same thing as negative 5 plus 1. You owe $5. You paid $1. Now you only owe $4. And that's that. Does anybody have any questions on this? Don't be shy. It's okay to ask. No penalties for asking a question. All right. Sounds good. Sounds good. So let's keep it moving. So, philosophical question here, right? What happens when there are more than three integers? We just use the orders of operations as usual, right? So let's take a look at this. This is going to look crazy, but we all know how to do this already, right? All know how to do this already. So I want to simplify 7 minus, open parentheses, -4 minus 3, close parentheses, minus 9, right? Now we all remember the order of operations, right? Please excuse my dear Aunt Sally, right? PEMDAS, right? First thing we do is parentheses. Next thing we do is exponents. Over here, this is going to be multiplication and division from left to right. And then finally, this would be addition to subtraction from left to right. Okay, so that being said, let's jump into this question. I have 7 minus, let's do what's in the parentheses. -4 minus 3, what does that become, somebody? What's -4 minus 3? Awesome, -7. Brilliant answer, that's good. So I have -7, and then I'll hear -9. All right, this might look confusing, but it's really simple. Just do it from left to right, the same way that you read a book. From left to right, the same way that you read a book, right? So 7 minus -7, what is that? What is 7 minus -7? What is that? Nope, not that. Ah, that's it. 14, right? That's 14. And why is it 14? Remember my stroke thing, right? We have 7, right? And then we're going to have the minus and then bring down the second stroke plus 7. And 7 plus 7 is what? 14, right? But we're not done. We're not done because that -9 is still there. So this is 14 minus 9. So somebody help me out. What's 14 minus 9? It's 14 minus 9. Excellent. Excellent. Good job. All right. So that's just 5. And that's my final answer. All right. So the moral of the story is we're doing our order of operations. Please excuse my dear Aunt Sally. And then, right, then we just want to do it from left to right. Same way you read a book, from left to right. Any questions on this? And again, it's okay if you have a question. Not mad at you. All right, if there's no questions, I'm gonna let you guys try one. Give y'all 2 minutes to try that out. right, let's take a look. Whoops. Awesome. Good job, everyone. All right. So I have, it's always happens. It's always happens. So I have 8 minus, right? Let's do the parentheses. -3 minus 4 is -4 minus 9, right? And again, from left to right, the same way you read a book, right? 8 minus -4, I'm going to rewrite as 8 plus 4 minus 9. And 8 plus 4, what's that? 12 minus 9. And then 12 minus 9 is just simply 3. All right. Any questions on this? Make sense? All right. Let's keep it moving. Let's keep it moving. About to take it up a notch. I know you guys heard me mention the M word a few times, so let's talk about it. So multiply and divide integers. So since multiplication is mathematical shorthand for repeated addition, our model can easily be applied to show multiplication of integers. Let's look at this concrete model to see what patterns we notice. We will use the same examples that we used for addition and subtraction here. We are using the model just to help us discover the pattern. So we remember that A times B means add A, B times, right? So 5 times 3 means I want to add 5 3 times. So 5 positive numbers, 5 more positive numbers, 5 more positive numbers, add them all together, boom, I get 15, right? Also, -5 times 3, right, means I want to add -5 counters, right, 3 times. So I have -5 circles here. I have 5 more negative circles here, 5 more negative circles here. Add them all together individually. -5 times 3 is equal to -15, right? Long story short, that's multiplication. Multiplication is repeated addition. That's all it is. For those of you in computer science, that idea might help you one day. Can't tell you how, but it might. All right. Next two examples are more interesting. What does it mean to multiply 5 by -3? It means subtract 5 3 times. Look at subtraction as taken away. It means to take away 5 3 times. But there is nothing to take away, so we start by adding neutral pairs to the workspace, right? Let's take a look at that. Let's take a look at that. Right. I think that's sufficient. Let's pick it up. So 5 times -3, right? We're going to take away 5 3 times, right? So we have 5 positive counters here, right? And then we're going to add, we're adding the neutral pairs, right? So 5 negative counters, 5 more negative counters along with 5 positive, 5 more negative counters along with 5 positive. We're taking away, right? We're taking away the positive counters 5 3 times, right? So knocking them out. Knocking them out. 1, 2, 3. So what am I left with? I'm left with -15, right? So I have 15 negative counters. So 5 times -3 is -15. Let's look at the reverse. I have -5 times -3. So I want to take away -5 3 times. So I'm going to add some neutral pairs there, right? I have my -5 counters. I'm gonna add 5 positive counters. -5 counters. I'm gonna add 5 more positive counters. I'm gonna add them 3 times, right? So 3 sets, negative, positive, negative, positive, negative, positive, right? I want to take away the -5 counters 3 times. So boom, taking them away right here. I have 1, 2, 3. And what am I left with? I'm left with 3 sets of positive counters, right? 1, 2, 3, right there. Right. So count them up individually. -5 times -3 is positive 15. Okay. This is multiplication in a nutshell. Do I do multiplication like this? Absolutely not. But if this helps you understand it, that's what I'm trying to get out of this conversation. I want you all to understand it. That is the most important thing here. All right, so in summary, 5 times 3 is equal to 15. 5 times -3 is equal to -15. -5 times 3 is equal to -15. -5 times -3 is equal to positive 15. Notice that for multiplication of two sign numbers, when the signs are the same, the product is positive. And when the signs are different, the product is negative. Remember that. This is actually how I do my multiplication. I remember these two situations here. Same sign, positive answer. Different signs, negative answer. Awesome. Now, I know somebody in the back of the class has their hands up and they're wondering, what about division? Got you. Got you. What about division? So division is the inverse operation of multiplication. So 15 divided by 3 is 5. And well, because, excuse me, 5 times 3 is equal to 15. In words, this expression says that 15 can be divided into 3 groups of 5 each, because adding 5 3 times gives 15. If you look at some examples of multiplying integers, you might figure out the rules for dividing integers, right? So 5 times 3 is equal to 15. -5 times -3 is equal to 15, right? So let's go in reverse. 15 divided by 3 is equal to 5, and 15 divided by -3 will give you -5. -5 times 3 is equal to -15. So -15 divided by 3 is equal to -5. 5 times -3 is equal to -15. So -15 divided by -3 is equal to +5. Division follows the same rules as multiplication with regards to signs. So a positive divided by a positive is a positive answer. A negative divided by a negative is a positive answer. Different signs is a negative answer. All right. Same rules. Same rules. And don't worry, I know somebody in the classroom right now is being real quiet, but they want to see me actually write it down because they're a visual learner and they want to see the words. I got you. Got you. Don't worry. So multiplication, division of sign numbers. So for multiplication, division of two sign numbers, same signs, two positives is going to be a positive. Two negatives is going to be a positive. If the signs are the same, right, the result is positive. Different signs, right? If you have a positive and a negative, you'll get a negative answer. If you have a negative and a positive, you'll get a negative answer. If the signs are different, the results is negative. All right, that's that. Any questions on this before we jump into an example? No, it's the same thing as the one I gave you. All right, let's jump into an example real quick. Let's jump into an example. Nothing crazy. We're gonna keep this simple, right? So instructions say to multiply or divide, right? So I'm just gonna look at A. So I have negative 100 divided by negative 4. Now, a negative divided by a negative, we know our answer is going to be positive. And 100 divided by 4, what's that, 25? And that's it. It's that simple. It's that simple. Let's look at B.
I got a question real quick.
Go ahead.
When there's two parentheses, you do PEMDAS, right? Or
Yes, you always do PEMDAS. In this case, inside of my parentheses is a whole number, so I don't really have to worry about that.
no, I'm saying if there's like two sets of parentheses, like a -4 in parentheses and a -3 in parentheses.
-4 and a -3. So like -4 divided by -3.
No, like parentheses -4, right?
Uh-huh.
And then minus parentheses -3.
Are you talking about the homework?
Like this.
Yeah, no, it's just a quick question so I can solve one of
Yeah.
the homework answers because I'm kind of stuck.
Yeah.
Yeah,
So
same.
so remember the negative and the negative now is going to become what? So that's
Oh, positive.
-4, right? Plus 3. And then now you owe me $4. You paid me 3. How much you owe me now?
$1 or -1.
Exactly. That's it. That's the answer.
All right, thanks.
You're welcome. Hold on one second. I'm just typing something real quick.
Wait, because I'm still kind of stuck. So what if you made that subtraction sign in the middle a positive? What would it be?
Subtraction sign in the middle positive. So you mean like negative? Let
Yeah,
me erase this real
put a
quick.
positive right there instead of a negative.
So like this.
Yeah.
So then that's just straightforward. So -4 plus -3. So you owe me $4. Now you owe me 3 more. How much you owe me now?
Oh, all right,
Right, like
-7.
that.
All
Yeah.
right.
All right, let's jump back into this real quick. So we got 7 times 6. That's a big number. I'm not gonna lie, right? We got 7 times 6, right? Just go about it straightforward. Let me think. 7 times 3, 21. So that's over 42. Y'all should check my math. Y'all know I'm not that good at math. Y'all better than me. All right. So let's look at C, right? I got 4 times -8. Oh, this is good right here. So a positive times a negative. So give me a negative answer, right? And then 4 times 8, what's that? 16 and 6 and 62. I think that's 32. So -32 is my answer. Not bad, not bad, right? Now I'm gonna do D a little bit different. I'm gonna do D a little different, right? Because I don't know if this is gonna help some of y'all. I have -27 divided by 3, right? I don't know if it helps for me to rewrite this. So I'm gonna rewrite this as -27 over 3. I don't know if that helps you to see that the negative divided by the positive is gonna give you a negative answer, right? That's all I want you to see. Then 27 divided by 3, I think that's like 9. And then that's it. That's another little trick. If it helps you, great, take it. If it doesn't help you, go back to the original way and use that way. All right. Like I said, all I want you guys to do is just get 100 and understand. Okay? Get 100 and understand. You guys try a little bit. So I had to, former students of mine, I met them outside before class, and they have like an event that's going on in the library, and they were just telling me how they just got so much free stuff over there because today's the club day with the club hours. So yeah, if you guys ever get a chance, check out Thursdays between 12 and 2. No pressure though. Just if you get a chance. So let's look at A. I have negative 115 divided by negative 5. You already know a negative divided by a negative is positive, and now 5 goes into 115 how many times? I feel like it's 23 times, but y'all should check me on that. I'm not sure.
Now you're right.
Right? Okay. I was guessing over there. And then let's look at B, right? Thanks, Beast. So the B, well, that's a little hard too. I got 5 times 12, right? So 5 times 12, I think is what, 60? Something like that. Right? You just multiply it straightforward, no pressure there, right? C, on the other hand, though, I have 9 times negative 7, right? Now, a positive times a negative is a negative. I'm gonna let you guys answer this. What's 9 times 7? I feel like 9 times 7 is the hardest timetable out of all of them. 63. Good job. Good job. 63. In my opinion, I feel like that's the hardest timetable that exists. All right, let's look at D, right? I have negative 63. Of course, that would come back, right? Divided by 7. And I saw someone say negative 9. Excellent, right? Because a negative divided by a positive is a negative, and then that's just 9. Is there any questions on this? Any at all? Any questions? Awesome. Okay. So let's move on. All right, I know this is common sense, but we got to go through it. All right, so when we multiply a number by 1, the result is the same number. Each time we multiply a number by negative 1, we get its opposite. All right? So that's a trick. Each time we multiply a number by negative 1, we get its opposite. All right, so multiplication by negative 1. Negative 1 times A is going to be equal to negative A. So multiplying a number by negative 1 gives its opposite. Okay. You guys remember PEMDAS? Just to emphasize it a little bit more. Simplifying expressions with integers. So what happens when there are more than 2 numbers in an expression? The order of operations still applies when negatives are included. Remember, please excuse my dear Aunt Sally. Let's try some examples. We'll simplify expressions that use all 4 operations with integers: addition, subtraction, multiplication, division. Remember to follow the order of operations. Let's take a look. Start out with some exponents, right? So I want to simplify negative 2 raised to the 4th power, right? Now, just so I'm clear, right? Negative 2 raised to the 4th power, the exponent. Exponents mean repeated multiplication. Repeated multiplication. So what does this mean? This means negative 2 times negative 2 times negative 2 times negative 2. That's what negative 2 to the 4th power means. So that being said, -2 times -2, we know is going to be +4 times -2 times -2. 4 times -2, we know is what? -8 times -2. And a negative divided by negative, we know is a positive, and 8 times 2, 16. And then that's my answer. Questions on this? Did that make sense? That made sense for everybody? All right. So let's take a look at something a little bit different. This is a little bit different. So B is -2 raised to the fourth power. Let me be clear about what this means. This means -1 times 2 times 2 times 2 times 2. Right? So notice how that negative is outside of the parentheses, right? So because the -1 is the negative, excuse me, is outside of the parentheses, right? It's being multiplied times the 2 to the fourth power. So this answer here is actually -16. Questions on that? Anybody? Right, because I'm keeping the negative. All right, if nobody has any questions, then you guys try this. Nothing crazy, something simple. Yes, you could think of the -1 as a placeholder for the negative symbol. Absolutely. So let's take a look. So for A, right? I have -3 raised to the 4th power, which again means what? -3 times -3 times -3 times -3, right? -3 and -3 we know is 9. I'm gonna do the same thing over here because my multiplication is not as good as you guys. And 9 times 9 is 81. All right. For B, change my color real quick. I'm gonna have -3 raised to the 4th power, which we know is -1 times 3 times 3 times 3 times 3. And in this case, it's gonna be what? -80. Questions on this? Everybody got this answer? Awesome, 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 awesome. Okay, let's move on. We don't have much more left. So just want to emphasize, right? The last example showed us the difference between open parentheses -2 raised to the 4th power and -2 raised to the 4th power. This distinction is important to prevent future errors. The next example reminds us to multiply and divide in order from left to right. Right? Again, these are those really nice, fun problems that you see on social media. Oh, I love those problems. And when they come up on like Twitter or Facebook or something, this must join right here. All right, let's take a look at this, right? I'm gonna look at A. So I have 8 times -9 divided by -2 raised to the 3rd power, right? So if I'm doing my order of operations, this is A, by the way. If I'm doing my order of operations, the first thing I gotta do is do the parentheses. There's nothing for me to do in these parentheses. The next thing that I have to do is my exponents, right? So I have that -2 raised to the 8th power and -2 raised to, excuse me, -2 raised to the 3rd power and -2 raised to the 3rd power. Again, I blurted it out by accident, is 8, right? So I have 8 times -9 divided by 8. And how do we want to do this? We want to do this from left to right, the same way that we read a book, right? So I'm going to have 8 times -9, which is what? It's going to be negative, what's that? 8, 8, it's 36. I think it's like 72 maybe. So -72 divided by +8. Ooh, see, I made a mistake there. Nobody even caught me and said anything. This is supposed to be -8. It's supposed to be -8. The reason why, -2 raised to the 3rd power is -2 times -2 times -2. And -2 times -2 is +4 times -2, which gives me a -8, right? So that was a mistake on my part. Anyway, back to what we were just talking about. Second. -72 divided by -8, and negative divided by negative is a positive, and 72 divided by 8, what's that? I think 9 is the answer. Somebody check me, I'm not sure if that's right. Then I'm gonna look at B. B looks all kind of fun right here. This is -30 divided by 2 plus -3 times -7. So in PEMDAS, I want to do my multiplication and division first, and then I can do my addition and subtraction. So -30 divided by 2, I think is -15, plus -7 times -3 is going to give me a +21. 1, right? Add these together, and I think my answer is positive 6. Questions on this? Anybody? Awesome, awesome. No questions on that? All right, before it's easy, that's good, that's good. All right, before you guys leave, I just want to introduce one new idea to you guys. I'm not gonna let you guys try this one out, but you will get to try it out on your homework. All right. Just remember your PEMDAS, right? Please excuse my dear Aunt Sally. But real quick, before you leave, I want you guys to check this out. And I am gonna ask you guys just to stay back for 1 or 2 minutes, just for like me to take quick attendance, and then you guys can leave at that point. So I want to evaluate variable expressions with integers. So remember that to evaluate an expression means to substitute a number for the variable in the expression. Now we can use negative numbers as well as positive numbers. So let me show you an example of what I'm trying to get into right here, right? Unfortunately, this example is a lot harder than what your homework is, but it's the same idea, right? So let's say I have this expression here, right? I have 4x squared minus 2xy plus 3y squared when x is equal to 2 and y is equal to -1. Very simply, everywhere you see a variable, you're going to put a parenthesis. So I'm going to have 4 parentheses here squared minus 2 parentheses plus 3 parentheses squared. And all I'm going to do is I'm going to plug in the numbers, right? So I have, what's this? X is equal to 2 over here. So everywhere there's an X, I'm going to write 2. And then I have what? I have Y is equal to -1. So everywhere there's a Y, I'm just going to plug in -1. That's it. And now we're back to the question that we had before, right? We're just going to do the math on this and see what happens. So now let me get a nice color. We'll do the rainbow now. All right. So remember exponents first, right? So I'm going to have 4 times 2 squared, which is, is 4, is equal to 2 times -1 plus 3 times -1 squared is what? +1. Then let's do our multiplications on that. I'm going a little bit fast because of time. 4 times 4 is 16. Why did I have an equal sign here when I was supposed to be a minus? Then we're going to have -2 times 2 is -4. -4 times -1 is +4. And then plus 3. Going to add these together. I'm going to get 20 plus 3, and 20 plus 3 is 23. Is there any questions on this? Any at all? All right, great, great, great. So I'm gonna let you guys try this one. I'm gonna put this up, and in the meantime, so this is gonna be a little bit longer of a try. I'm just gonna take a last minute attendance, and then we can wrap it up after this question. Homework is already posted, so if you wanna take a look at it, try it. I know some of you probably are done with your homework and the weekend didn't even start yet. Good for you. All right, I think I got everybody. Some people are missing, but I think it's because they didn't show up. So anyway, let's take a look at this question real quick and then you guys can go. My technique, my recommendation to you is everywhere you see a variable, you write a parentheses everywhere. So I have 3x² minus 2 times x is a variable, times y is a variable, plus 6 times y, and then squared, right? Boom. After that, all we got to do is just write in our numbers here. I have x is equal to 1, so I'm just going to write in the 1 everywhere I see the x. And I have y. I need a nice color, nice color, nice color. What we going to do? What we going to do? Let's do this crimson color right here, right? So I have y is equal to -2, so I'm going to write in -2 and -2, right? After that is straightforward, right? We just do our math the way that we know how, right? Exponents first, so 1 squared we know is just 1, so 3 times 1 is -2 times 1 times -2 plus 6 times -2 squared we know is +4. Let's do our multiplications now. 3 times 1 is 3. -2 times 1 is -2. -2 times -2 is +4, right? Plus 6 times 4, what's that? 6 and 6 is 12, I think 24. After that, you just want to add straight across. 3 plus 4, I believe, is 7 plus 24. And 7 plus 24, I think, is 31. Any questions on this? Any at all? Which one is 1, Franklin? Which one is 1? Questions on this final problem? No? Okay. Well, I guess that's it for today. If you guys have any questions, shoot me an email. On Tuesday, I'm gonna have a confirmation about tutoring in terms of like the days and the times. I'm not 100% sure if what I told you today is all correct. All right. Yeah, so Tuesday we'll verify everything. All right. Try your homework. It's not that bad. You guys can work together. You can use the calculator. You can I'm gonna give you the formula sheets on Tuesday, right? The only other thing Tuesday is class in person, yes. The only other thing that I didn't get to share with you guys was the calculator. So if you give me like 2 seconds real quick, I'm gonna bring up the calculator at Staples. Then I'm gonna tell you something about it. So the calculator that I recommend is called TI-36X Pro, right? TI-36X Pro. Now, there's many reasons why I recommend this calculator, but probably my number one reason for those of you studying engineering, I forget how many people that is, right? This is the only calculator allowed on the fundamental engineering exam. So this calculator should be your best friend. Just telling you straight up, that should be your best friend, right? That's the link for the calculator. Now, when you go onto the website, you're gonna see a price for that calculator. You do not have to pay that price if you don't want to. Go on to any other website that you go to buy something, Walmart, Amazon, whatever, right? Find a cheaper price for the calculator, right? Whatever price you find, you can go to Staples in person and show them that price and they will match the price for you. So if you find it for 15 bucks at Walmart, for example, and you bring that to the cashier and you show them like, listen, on Walmart.com is $15 or whatever. they'll match the price. So instead of paying the 22, it'll be 15. Right? Let's see. Gotcha. I see that you messed up on not multiplying the 6 and the 4. That happens to all of us. I was about to make a mistake too with the negative. I was about to write an equal sign by accident. No, this is not the homework for the month. This is just the homework for today. There'll be more homework every day that we have class. No, the homework will not always be 20 questions, right? Just that this topic is like really, really, really simple. You're gonna see towards the end of the class, the homework is gonna be very, very small, sometimes 3 or 4 questions, you know? But in the beginning, the homework is a lot because it's easy, just to get more practice in. Yep, I'm just giving you guys extra time. I mean, if you can finish all the homework in one day and get on with your life, good for you. You know? Like I'm just trying to make it as easy as possible. You can use a TI-84 as well, you know. But like I said, it really depends on your major. I'm kind of looking out for the engineering majors in the class by recommending this calculator, not to mention that this calculator is way cheaper than the 84. 84 is so expensive, but it's a good calculator and it'll work for this as well. Another thing that I didn't get to tell you, I don't have time in this class to teach you the calculator. So if you have time to go to tutoring, that would be the time to learn how to use the calculator. And I'll be happy to teach you in tutoring how to do it. Wow, you found the 84 for $100. That's amazing. That's a lot cheaper than what I thought it was. Back when I was in high school, the 84 was like $2.8 million. That's amazing. That sounds really nice. Not every school does that. So that's it for today. Anybody has any other questions? I'll put the calculator link in the announcements for everybody in case you guys missed that. Those of you that came in late, again, everything is recorded, so you can just go back and watch the recording at a later time. No pressure. All we did today was just operations on integers.
All
Have a
right,
great
thanks.
day as well.
Have a
All
good
right.
day, Mr. Lee.
You're welcome. You're welcome. Have a good day, y'all. You're welcome. You're welcome. Have a good day. Talk to you soon. All right. See you next week. Have a great weekend and happy Labor Day. Thank you. Thank you. All right. If there's no more questions, I'm gonna end the recording. Thank you. Thank you. All right. Have a great weekend. Catch up with you next week. See you all on Tuesday.